Okay, having a look at our Year 9 Maths quiz for week 7. We're doing another proving similar triangles one to start, but adding in the bit about finding x. So to start with, I'm going to look at my shape. I have 3 numbers there, which means I can't get 2 matching pairs, which means for my similar triangles coded reasons, I could have 3 sets of matching sides to scale. I could have 2 sets of matching sides and an angle, 1 set of matching angles. I could have RHS, which is my right angle, hypotenuse, and a side length. I don't have any right angles, so that one's out. Or I can do the AAA. That's the one I'm going to look for because I don't have 2 sets of sides to get scale factors to show they're the same. So I need to work on my angles. For starters, I can see that this angle here must equal that one there because of opposite angles are equal. So I'm going to write that with my angle notation. So angle CBA is equal to angle EBD, and that's because of opposite angles are equal. I'm then going to use my parallel lines and do my Z rule to show that these two are equal here. So I'm going to put this little notation there and just put a dot on those ones. So these 2 angles are equal. I could say angle C is equal to angle D, or I could list the 3 because there's no other angles around there. Here at B it could have been this one, this one, this one, this one. So that's why I had to be more specific. Here I could say angle C is equal to angle D, and my reason is the Z rule. Then I could go the other way with the Z and say these 2 are equal. So angle A is equal to angle E. Or I could use the fact that I know 2 of the angles are matching, therefore the third has to be matching because they have to add to 180. But I can prove these ones anyway using the Z rule. So that means my coded reason is AAA. And now I can write my similarity statement. So that triangle ABC, so I'm starting here at A, which means when I write my next triangle, I have to start at E because that's the corresponding starting point there. And then I went to the middle, so EBD would be how I write that. Finding the value of x, I need to get the scale factor to be able to do that. And because I've got 2 sides that match or correspond to each other, that can help me find the scale factor. So my scale factor is going to equal 5 over 2, which is 2.5. Now, if I've got the 3 here, I can find the x by multiplying by that scale factor. So my x is going to equal 3 times 2.5. So I can grab my calculator and do 3 times 2.5, and I get 7.5 as my answer. I don't have any units, so I can just leave it as 7.5. For question 2, we've got a bunch of triangles, so we're deciding, are we using Pythagoras theorem or are we using our trig ratios? Now I've written those rules down the side here to look at. So the first 2 I know have to be Pythagoras theorem because there's nothing about any angles in that triangle other than the right angles. If you look down here, we've got an angle there, we've got an angle there, and we're asked to find this angle here. So they're going to be our trig ratios, and these are going to be our Pythagoras theorem questions. So I'm going to write my c squared equals a squared plus b squared on both of those to start with. My next step is to label the sides. So I need to label with A, B, C. The A and B don't matter too much, but my C I have to have in the right spot. My C is always going on my hypotenuse, which is the longest side, and the one opposite the right angle. So in this first one, my C is on the X. In this second one, my C is on the 6. Then I can put the A and B wherever I want. So now I'm going to fill those values into my rule. So I've got the X is with the C. With my A, I've got 5 squared and 7 squared. So I can work that out on my calculator. 5 squared plus 7 squared. I can type it in like that and I get 74. So that means my x is going to be the square root of 74. and I get 8.6. Now I've got the unit there of centimetres, so I'm going to pop that in. In my second one, I'm going to put in what I know. With the C is going the 6, with the A is going the 2, and then my X is where the B is. So I've got 36 is equal to 4 plus X squared. Now I want to get that X squared on its own, so I'm going to do 36 take 4 is equal to X squared, which gives me 32. That means my X is going to be the square root of 32. And I get an answer of 5.65 or 5.66. And that is meters. As I said before, C, D, and E are going to be my trig ratios. So I'm labeling with A, O, and H for each of those. So for the first one, I'm looking at my angle here. So my A is going to go there, my H is going to go here, and my O is going to go over there. Here my angle is there, the 70 degrees. My H is going to go with that X. The A is going to go down here next to the angle, and the O is going to go with the 5. In the last one, my angle that I'm referring to is there. So my H goes with the 10, my A is going with the 6, and my O is going there. Now I can then look at what letters I have something with. So in the first one, I have O and A, which means I'm going to use tan theta equals opposite over adjacent. In the second one, I've got O and H, so I'm going to use sine theta equals opposite over hypotenuse. In the third one, I've got A and H, so I'm going to use cos theta equals A over H. Once I've decided on my ratio, I'm then going to put those values in. So I'm going to put in tan of 50 is equal to X over 11. The 11 is on the bottom, so I'm going to multiply tan 50 by 11, so I get 13.1 or 13.11, and that is meters. For my next one over here where I've got sine, I'm going to write sine of 70 is equal to 5 over x. The x is on the bottom, so I need to make these switch sides. So x is equal to 5 on sine 70. So I grab my calculator. 5 divided by sine 70 is equal to 5.32. And that is centimeters. Then my last one here, I've got my cos theta is equal to adjacent over hypotenuse. Now I've got cos of x is equal to 6 over 10. I want to get that x on its own. The opposite of having cos of a value is to do cos to the -1, or the inverse of cos. So I'm going to grab my calculator, do second cos, that's how I get to that part, 6 over 10, and then I get 53.13 degrees. Going on to the second side, we have some distance, Pythag again, and some surface area, volume, and area questions. So the first one, looking at the distance between 2 points. We have this rule down the side here. D is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Now here I can write my x1, y1, x2, y2, and sub them into that rule. So I've got 11 take 5 squared plus 7 take 3 squared. I'll grab my calculator and I can type that all in one go. So we've got bracket 11 take 5 bracket squared plus bracket 7 take 3 bracket squared, and then I press enter, and then I just need to press that little arrow button to get that to change it to the decimal for me, and I get 7.211. We don't have any units again, so we leave it as that. The next one says determine if a triangle with lengths 5, 7, 10 is a right angle triangle. So this is where we're using our c squared equals a squared plus b squared to test out if it's a right angle triangle. We know that our C is always the biggest side, so that means we know we've got the 10 squared there. 5 squared plus 7 squared goes in. It doesn't matter which one we put in the A and B. 10 squared is 100, 5 squared is 25, 49. 25 plus 49 is not going to give us 100. We get 74. So then we know that this is not a right angle triangle. For number 6, we've got surface area. Now surface area of a cylinder is going to be the 2 pi r squared plus 2 pi r h. So we're going to do 2 times pi times, now the key here is that's for the whole way across, so r is equal to 2.5. 2 times pi times 2.5 times, now the other thing is this is in millimeters, so I need to change that to centimeters, and I get 6 centimeters there. So I get 39.27, and then 2 times pi times 2.5 times 6 gives me 94.24. I'm going to add that, oops. So I get the 94.24, and I'm going to add that to, I need to put my plus there first. I might just type that in, 39.27 plus 94.24 gives me 133.51. And that will be centimeters squared. We could have had chosen the option of changing this one to millimeters, but we get a really big number in millimeters squared, and it's better to have it in the centimeters squared. Here we've got to find the volume in litres of this shape. Now we've got the area of the base, we've got the height, so volume is area of base times height, which is 5 times 2, which will be 10 meters squared. Now I know that 1 meter, oh sorry, not 10 meters squared, 10 meters cubed. I know 1 meter cubed is equal to 1 kiloliter. So that means we've got 10 kiloliters, but we want liters, so we need to times by 1,000. So we will have 10,000 liters as our answer. The last one I'm putting in because my students are getting this one, still finding this one tricky, so I'm trying to make them practice that. So our area of a sector is theta over 360 pi r squared. We've got 80 over 360 for this one, times pi times 11 squared. So I'm going to grab my calculator, do my 80 over 360 times pi times 11 squared, and I get 84.47, and that is centimeters squared.